In this lesson, students will be able to understand the unique characteristics of division. Albert Einstein stated, "Education is not the learning of facts, but the training of the mind to think." This lesson does just that. Math Talk is incorporated into the lesson to facilitate discussion, deep thinking, and visualizing mathematics. We will start off our lesson with the question, what is 400 divided by 4? We know that 4 times 100 is 400, therefore, 400 divided by 4 is 100. We can illustrate our thinking using the area model. If we add an additional area of 160, we can brainstorm what the answer to 560 divided by 4 is. We can gather that the other factor is 40 because 4 times 40 is 160. Therefore, 100 plus 40 is 140. This illustrates 560 divided by 4 is 140. In class, your student will discuss how each of the sides of the equation are equivalent. Possible answers could include 560 was decomposed into 400 plus 160. They may notice that the 400 and 160 are compatible with 4, making a good mental math strategy. Students may even say it reminds them of the distributive property. Next, we will look at the problem and decide whether it is true or false. Is 80 pieces of candy shared with 4 kids the same as 80 pieces of candy shared with 2 kids, plus 80 pieces of candy shared with 2 kids? Let's think about that for a moment. The equation is false. One of the mathematical practices is to construct viable arguments and critique the reasoning of others. It isn't good enough for a student to say this is false. We want to know why. What thinking is happening? How is the student visualizing this scenario? We are going to go over different ways to show and justify why this equation is false. Mathematically, 80 divided by 4 equals 20, and 80 divided by 2 equals 40. 40 plus 40 is 80. The equation is false. 20 does not equal 80. In this lesson, students will notice the difference between multiplication and division. In multiplication, we can decompose either multiplier. In division, unlike multiplication, only the dividend can be decomposed into addends, not the divisor. For example, if I decompose the dividend into 40 and 40, I can divide 40 divided by 4 plus 40 divided by 4 to equal 20. Now our equation is true. 80 divided by 4 equals 20. Next, we can use the area model to show that the equation is false. The entire area of this rectangle is 80. I then put my 2 and 2 on the other side, totaling 4. We then would calculate 80 divided by 2 twice and add it together. Visually, we are using the same area of 80 twice. It doesn't make sense. If we use our divisor of 4 and break up our dividend into 40 and 40, we can see that 4 goes into 40 10 times, and 4 goes into 40 10 times again. 10 plus 10 is 20. This visual shows that we can decompose our dividend, but we can't decompose our divisor into addends. Last, we will look at this same situation as fractions. 80 divided by 4 can be written as 80/4. If our whole was 80 and we divided it into 4 equal partitions, each partition is 80/4. Since one section is shaded, it represents 80/4. If we took 80/2 plus 80/2, I would be adding half of 80 twice, which would equal a whole. This illustration shows that these are not equivalent. Thus, the statement is false. We can fix our demonstration to make the situation true if we decompose the dividend rather than the divisor. We can decompose 80 by decomposing it in half, 40 plus 40. We will divide 40/4 and add it to 40/4. This shows an equivalent equation, and our representations justify our reasoning. This lesson focused on the divisor not being able to be decomposed into addends. That does not mean it can never be decomposed. It can, however, be decomposed into factors. The example 80 divided by 4 is sometimes written 80 divided by 2 divided by 2. But because this division is the inverse of multiplication, it can more easily be seen as 80 times 1/2 times 1/2. In the strand, Numbers and Operations of Fractions, 5th grade students will learn more about this concept. The objective for this lesson was to understand the unique characteristics of division In this lesson, we found that in order to decompose a division expression, only the dividend can be decomposed into addends before the divisor is distributed. We met this objective by justifying our reasoning mathematically with area models and fractions. We discussed the importance of math talk as students justify their reasoning of mathematics.